discuss about the kinetic or sliding friction. In the previous video, already I have given about the friction, limiting friction, and limiting friction or maximum static friction, and then laws of limiting friction. And today I am going to discuss about the kinetic or sliding friction. The force acting between the two surfaces in relative motion is called what here? Kinetic or sliding friction. Again, listen here. The force acting between the two surfaces in relative motion is called kinetic or sliding friction, and this kinetic or sliding friction is denoted by Fk. And this kinetic friction is slightly less than the static friction. And we can also experience in our daily life. Suppose if any bus, मान लीजिए कोई बस खड़ी है और बस को स्टार्टिंग में 10 लोग मिलके पुश कर रहे हैं, because earlier it was in rest, there was a static friction between the tire and the ground. But when once it moves, पहले मान लीजिए 10 आदमी ने ढकेला, but once when it moves, then now the kinetic friction will start to act, and the kinetic friction is less than the static friction. तो ऐसे केस में 10 के बजाय अगर 8 भी लोग अब ढकेलेंगे तब भी वो मूव करता रहेगा. So in this way you can say kinetic friction is slightly less than what here? The static friction. Now laws of kinetic friction. Earlier in the previous video already I have given you the laws of static friction, and now here laws of kinetic friction. So first law is what here? The force of kinetic friction is independent of contact area between the two bodies, provided the normal reaction remain constant. Second one, the kinetic friction is almost constant for a given pair of two surfaces placed in contact, and it acts opposite to the direction of relative motion. It means for a given pair of surfaces, for a given pair of two surfaces, the kinetic friction is remain constant, and it always acts in a direction opposite to the direction of relative motion. And third law, the force of kinetic friction is directly proportional to the normal reaction are present between the two surfaces. And you can write here Fk is directly proportional to R. And when we remove the proportionality constant, then here we introduce a new constant, and here that new constant is what here? Mu k. So you can write Fk is equal to mu k R, where mu k is a proportionality constant, and that proportionality constant is called coefficient of kinetic friction. And from here you can say mu k is equal to Fk upon R. It means coefficient of kinetic friction is the ratio of kinetic friction to the normal reaction. Now, a graph of frictional force versus applied force. And already I have told you in the previous video, a frictional force is a self-adjusting force. इसका मतलब जैसे जैसे हम एक्सटर्नल फोर्स हम बढ़ाते हैं, स्टैटिक फ्रिक्शनल फोर्स भी क्या होती जाती है? अपने आप बढ़ती जाती है. और जब ये स्टैटिक फ्रिक्शनल फोर्स अपने मैक्सिमम वैल्यू पे पहुंच जाती है, जिसे क्या कहते हैं? लिमिटिंग फ्रिक्शन. मींस मैक्सिमम स्टैटिक फ्रिक्शन इज इक्वल टू व्हाट? इट इज कॉल्ड static friction, limiting friction. So as we increase the applied force, then initially automatically the static frictional force is what here increases. जैसे हमने बताया था कि मान लीजिए हमने फोर्स लगाया F1, frictional force हो गया small f1 and body is in rest. When external force is increases from capital F1 to capital F2, and suppose body is remain in rest, it means the frictional force is increases from small f1 to small f2. In this way you can say a frictional force is a self-adjusting force. So when you will draw a graph between frictional force versus applied force, suppose frictional force is acting along y-axis and applied force is taken along x-axis. So in this graph, from A to you can say here B. Suppose this is A to B. This one is a straight line, and this straight line reason represent that as we increase the applied force, जैसे जैसे हम applied force बढ़ाएंगे, in same proportion the static frictional force will also increases. And for certain value of the applied force, this static frictional force is reached to its maximum value. And when the static frictional force means at this point will reach at its maximum value, so this one is called maximum value of Fs, means maximum value of the static frictional force, which is called its limiting friction. And so from A to C, this region is called what region? A static region. And in this region, your frictional force is directly proportional to the applied force. Here at the point B, then the body is just start to move. And you just start to move means till that the body is remain in rest. अभी move करने वाली है. And when we increase the external force beyond this, then body comes in motion. And when body comes in motion, then now kinetic friction will start to act. And kinetic friction is less than maximum static friction. इसीलिए ग्राफ यहाँ से थोड़ा सा घट गया. इसका मतलब यहाँ maximum static friction से जब kinetic friction में आएगा तो kinetic friction maximum static friction से कम हो जाता है, घट जाता है. तो kinetic friction is slightly less than the maximum static frictional force. And in this way, then the body, a constant kinetic friction will start to act. So from B to C, all this region represent what here? This region represents the kinetic region. So this one is a static region and this one is what here? Kinetic region. This ink point shows that when the body comes in motion, then kinetic friction is slightly less or decreases than the maximum static friction. Now next topic which is very important, what is angle of friction? And how can we define the angle of friction? In the state of limiting friction means maximum static friction here. So in the state of limiting friction, the angle which the resultant P makes with the normal reaction R is called angle of friction. And this angle of friction is denoted by theta s. If this angle is theta s, means theta s is angle of friction. किसके बीच का angle है? Resultant P and normal reaction R. और resultant P क्या? Now you see, suppose this one is a surface and this one is not frictionless surface. There is a friction. There is a friction in the surface. A block of mass m is placed over it. And that block is pulled by a force, external force F. So a frictional force arises in opposite direction of the tendency of motion of this block. Since the block is moving forward, so a frictional force is developed backward direction, Fs at the contact point. And Fs is what here? This is in the state of limiting friction, means this one is maximum static friction. In this case, the weight of this block mg will act downward. Normal reaction of this surface on this block will act upward. Applied force F and this frictional force Fs, means till that the body is remain in rest. So now you see this one is Fs, static frictional force. This one is normal reaction R. Angle between them is 90 degree. Suppose the resultant of this normal reaction force R and this Fs, frictional force Fs, is P. Fs और R का मान लीजिए resultant force कितना है ये P. तो resultant हमने किसका लिया? This frictional force and normal reaction R. And the angle between this resultant P and normal reaction R, जो कि ये है, this angle theta s, which is called angle of friction. And from this triangle you see, remember this, here P is the resultant of normal reaction force R and this frictional force Fs. And from here you can say tan theta s. ये एक right angle triangle है, ये देखिए. तो tan theta s you will write perpendicular upon base. So perpendicular means along this one which force? Fs. And along perpendicular this one and base what you will take? Normal reaction R. So tan theta s is equal to Fs upon R. But But Fs by the law of static friction, huh? by the law of static friction and limiting friction, we have given here Fs is equal to mu Sr. So by laws of limiting friction, you can write Fs is equal to mu Sr. So you can write here at place of Fs mu Sr. So tan theta s is equal to mu Sr upon R. Now R is cancelled by R, and you can write tan theta s is equal to mu s. Remember this. What is theta s? Theta s is called angle of friction. Tan theta s means tangent of angle of friction. मतलब एंगल ऑफ फ्रिक्शन जो भी है उसका अगर हम tan ले लें तो वो जो वैल्यू आएगी वो किसके बराबर होगी? कोफिशिएंट ऑफ स्टैटिक फ्रिक्शन की. जैसे हम कह दिया कि अगर एंगल ऑफ फ्रिक्शन है 45 डिग्री तो उस सरफेस के लिए कोफिशिएंट ऑफ फ्रिक्शन कितना हो जाएगा? tan 45, and tan 45 means 1. So in this way you can find the tangent of angle of friction, which is equal to the coefficient of static friction. So theta s is what here? Theta s is the angle between the resultant P and normal reaction R, and by definition this angle is called angle of friction. Now next topic is friction on an inclined plane. And now here I am not taking the horizontal plane. Friction on an inclined plane, and that one is also called our angle of repose. So these two terms is very important. First one angle of friction, and second one is angle of repose. So angle of repose is considered in the case of an inclined plane. And how can we define the angle of repose? The minimum angle of an inclined plane with the horizontal. The minimum angle of an inclined plane with the horizontal at which when a block be placed, then that block is just start to slide. मतलब कि किसी भी inclined plane का वो minimum angle horizontal से जिसके लिए अगर कोई ब्लॉक उस inclined plane पे रखा जाए तो ब्लॉक just start to slide, लेकिन अभी slide की नहीं है, just start to slide. वो angle of inclination with the horizontal is called what here? Angle of repose. And how can we calculate this angle of repose? Suppose, first definition, the minimum angle of inclination of a plane with the horizontal at which the body placed on it just begins to slide down is called the angle of repose. It means जब तक कि ब्लॉक अब इस जैसे हमने कहा दिस वन इज inclined plane, its minimum angle with the horizontal theta s, and for this angle theta s when the block is placed over it then it just begins to slide. अगर इसका मतलब this angle is अगर इस inclined plane का angle theta s से कम है तब तो ब्लॉक इसमें परमानेंटली रेस्ट में रहेगा. अगर थीटा एस से थोड़ा सा भी ज्यादा हो जाए तो मूव कर जाएगी. इसका मतलब जब थीटा एस के बराबर होगा तो जस्ट स्टार्ट टू स्लाइड, बट टिल दैट द बॉडी इज इन रेस्ट, इट इज इन स्टेट ऑफ किसका है? मैक्सिमम स्टैटिक फ्रिक्शन. So suppose this block be placed on this inclined plane, its weight mg, suppose the mass of this block is m, so its weight mg will act downward, and reaction of this inclined plane on this block, this one is normal reaction which makes angle 90 degree with this surface. And when we extend this normal reaction in the backward direction, so angle between this weight and this this extending normal reaction force, this angle is same angle this one. Component of mg along this direction mg cos theta s, and component of mg along this direction is mg sin theta s. And since the tendency of this block is to slide down, so in static frictional force, maximum static frictional force Fs is act opposite to this sliding direction. ये क्या है ये Fs? Limiting frictional force. और चूंकि ये ब्लॉक अभी तक रुका है, just begins to slide, मतलब अभी भी ये रुका है. It means all these forces which act on this block are balanced to each other. कौन force? चूंकि हमने mg का कंपोनेंट ले लिया, mg cos theta s, mg sin theta s, तो फर्दर नो नीड टू टेक द mg. अब क्या क्या बचा? r mg cos theta s, mg sin theta s, and this force is fs. And since the block is remain in rest, it means all these forces are balanced to each other. So you can say r is balanced by mg cos theta s. So we can write here r is equal to mg cos theta s, equation 1, and fs is equal to mg sin theta s, and fs is equal to mg sin theta s. This equation number 2. And when equation 2 divided by equation 1, then we can write here mg sin theta s upon mg cos theta s. You can write this is equal to fs upon r. fs upon r or this question. mg is cancelled by this one. Sin theta s upon cos theta s. You can write tan theta s is equal to fs upon r. And by law of the limiting friction, fs is equal to mu sr. But fs is equal to mu sr. So you can write if fs is equal to mu sr, then tan theta s is equal to mu sr upon r. Now r is cancelled by r, and again you will get tan theta s is equal to mu s. It means tan of angle of repose is equal to also the coefficient of static friction. So in this way, you can say here, either in the case of angle of friction or in the angle of repose, you can find the expression, or you can find the relation between the angle of friction or angle of repose with the coefficient of the static friction. So dear student, today you go through this topic what I have taught in this video here. In next video, I will discuss the types of kinetic friction and then motion along a rough inclined plane. Thank you.